Starting recording. Yeah, okay, right. So, welcome everybody to this webinar on groundwater flooding. I'll introduce you to David Macdonald, our specialist. And without any further delay, David, I'll hand over to you.
Thanks very much, Jean. I'll just start up now. Give me a second. And there we go. So hopefully you can all see that slide that says living with groundwater flooding. You can see it okay, Jean, as you're the only one that's not mute.
Yes, yeah, everything's fine. Yes, we can see that.
Great. Okay. Thanks very much. Thanks, Jean and Tracy, for the invite. Seem to. Okay,
yeah, sorry,
you
sorry,
can hear
David,
me now.
that was my fault.
That's right. Yeah, so thanks to Jean and Tracy for the invite. I'm going to be talking to you about living with groundwater flooding, the title that Jean has asked me to speak on. Now, just to give you a little bit of background on myself, I live in a area that is prone to groundwater flooding. I live in South Oxford. I've lived here for about 30 years, and this is a picture of me in my back garden, standing in groundwater flood water. The other kind of reason why I have got some experience that may be of value and I mean that I can talk to you is that I'm also part of the South Oxford Flood Action Group, which is a relatively young organisation, but it is one that is thriving, and hopefully we're going to be doing good works in the South Oxford area. We are supported at the moment by Project Groundwater, which is a DEFRA-funded project. It's run by Buckinghamshire County Council, and it covers Oxfordshire, West Berks, Hertfordshire, and other places. But they have been very helpful in sort of helping us develop as a group. The other thing I should say is that I have recently retired from a 35-year career in the British Geological Survey, where I specialised in groundwater, and one of my particular areas of expertise was in groundwater flooding. So this is just a paper just to show you that is the case. So I come from a background of I've experienced groundwater flooding myself. I know about the kind of science. I suppose what I don't have is a huge amount of experience of sort of dealing with kind of legislation and how that's applied in the local area, but I do have some experience, and so we will touch on those areas. So this is the kind of outline that that Jean had put to me, but we're very much kind of fitted in with what I'd planned. So given that I expect there'll be some of you out there that don't know a great deal about groundwater, I'll start by kind of discussing what groundwater is, go on to talk about the impacts of groundwater flooding before sort of addressing the causes. And then we'll talk about kind of responsibilities around flood risk management and planning. And then a little bit about what people can actually do before going into the questions and answer sessions. And some of that will be kind of help to unpack some of that responsibility aspect. So what is groundwater? Groundwater is the water that sits within the saturated rocks that are beneath our feet, and they're held in the pores and the fractures. If you look at the bottom left of the screen, you see a view of some sands and gravels. They're kind of river-related sediments. To the right of that is chalk rock, so that is more a sort of consolidated bit of rock which has its pores, but also has its cracks and its fractures, and water can flow through both of these types of rock, either sort of through the pores or through the fractures, or a combination of both. And we call a rock that does allow a significant amount of water to be stored and to flow through it, an aquifer. And then if we look on the right, this is a little schematic that shows us kind of, where the groundwater sits within the profile. So let me just move that there. Water that lands on the ground surface, it percolates through the soil water, keeps going vertically down until it reaches the saturated rock. And the top of that saturated area is called the water table. Now, if we look at that in a kind of in the context of the hydrological cycle, that water, that saturated rock, the water doesn't just sit there; it kind of moves around. It arrives, as I said, as rainfall. It then soaks down through into the ground, hitting the saturated zone, and then water will move off. It'll move off primarily towards the sea, so lots of it will sort of discharge at the coast. Some of it will also discharge into sort of low-lying areas or lines, and those are rivers. And it's that base flow of groundwater that keeps the rivers moving, flowing during the periods where there's sort of sustained periods of no or low rainfall. So groundwater is kind of key to the whole hydrological cycle. The other places where groundwater can discharge is at springs as well, so which is shown over to the right in the figure. There is another way that groundwater is discharged from aquifers, and that's through boreholes, which are pumped for use either agriculture or industry, but also crucially to provide water to us, to people. And that's where there's some sort of potential conflict between the amount of water that we pump out for abstraction and the amount that goes into the rivers or sits sort of within our wetlands. We need to have a balance between groundwater that sustains life and groundwater that sustains the environment. So that was a whistle-stop tour of groundwater. If we now think about groundwater flooding, what are the impacts? I'll talk about this before I talk about the causes. I think it's kind of because a lot of the kind of impacts are kind of are not dependent on the causes. They're kind of universal. So before we start, let's have a definition just so we are all on the same page. I think the key thing here is that groundwater fluctuates normally, naturally. Groundwater can come up to the ground surface as part of a sort of natural seasonal variation. It's when it goes well beyond its normal ranges that we have issues. And the sort of two types of kind of impact of groundwater that go out of its normal range are emergence of groundwater at the ground surface or the rising of groundwater up into man-made ground. And we'll talk a little bit more about that in a bit. There is another kind of, I suppose, category of groundwater flooding, and that is where, due to human influence, that kind of base groundwater level has changed over the years. And so we're now in a situation where we may just get sort of what you call the new normal in terms of groundwater fluctuation, but that results in frequent flooding. So it's not kind of outside the new normal ranges, but it's because of human influence that groundwater is in the wrong place or in the place that we're not used to it being. Okay, so in terms of impacts of groundwater flooding, as I say, we have water at the surface in low-lying areas, or in some occasions, anomalous discharges causing water to flow down slope. And we'll talk a little bit more in a moment about, well, particularly about the areas of chalk where you get when groundwater levels are abnormally high, you get water popping out in places in springs that it hasn't normally come from. And both this water sort of in low-lying areas and coming down slopes will affect property. It'll affect transport routes, as it's done in the photograph in the top right. It'll affect public amenities. It will, and then there's also the situation where the groundwater hasn't actually come up to the ground surface, but it's inundated basements and subsurface infrastructure. And that can lead to the damage of property, transport network, electrical and telecom systems. So the photograph in the middle right shows a basement where groundwater levels have come up and are now inundating the property, causing problems. But this can also be an issue with the transport network. So, for instance, where you have groundwater inflowing into tunnels, or, for instance, the underground network, and that this has been a problem in the past in London. And then there's also the issue of groundwater infiltrating into the sewerage and the drainage network. And we've got a photograph on the bottom right here of water that's kind of pouring into a sewer system. And this is becoming a sort of major issue within the UK. It can result during times that toilets are inoperative. It results in the sewage treatment works being overwhelmed with the need to pump wastewater from the network. And in terms of drainage, it also reduces the capacity for storm waters. So you may get groundwater flooding of the drains, and it means that sort of subsequent storms that occur, there won't be the capacity to take that storm water away. There are other impacts, and maybe some of these are sort of maybe less apparent, or in the UK less important. But when you get groundwater levels rising, it changes the hydraulic pressure. So you have the pressure of water on buildings, on tunnels. That can even be where groundwater is coming up close to the surface. Pressure on roads from beneath, as is the case in the top photograph, top right. It can also kind of cause instability in things like flood defenses, and that was an issue that was is shown in the center photograph on the right. And as I sort of intimated in terms of, sort of the drainage network, it can also mean the reduced capacity of retention ponds. So if groundwater levels rise and those ponds are kind of filled with groundwater, again, it sort of affects the ability of the system to deal with sort of consecutive storms. Thinking more sort of longer term issues, it can also have an impact on terrestrial ecosystems, because it's reducing the amount of oxygen in the root system, because it's saturating the ground. And it also can cause, in a similar way, damage to agriculture, but that can also be through waterlogging that kind of impacts on the ability of farmers to get their machinery onto the fields. And the photograph on the top right is actually an example of that. But the other issues to do with groundwater flooding are more sort of from a groundwater quality perspective. So, and this is a big issue in the developing world, is where you get very high groundwater levels. You get poor performance of on-site sanitation, so you don't have that kind of you don't have that sort of unsaturated zone that allows the microbes to break down the waste that goes into pit latrines. But you can also have inundation of landfills as groundwater levels rise. And then there and elsewhere, the mobilization of pollutants that have kind of historically been put onto the ground surface as waste before sort of properly designed landfills were in place. all of this kind of polluted groundwater can have can cause damage to underground structures. It can cause the kind of metal rods within structures and the cement to break down. But it also can cause contamination of water supplies and aquatic ecosystems. So, and we're thinking, and we'll talk about it in a bit, about the impacts of what sea rise does at the coast on groundwater, and that can cause the ingress of saline water inland, which can cause the sort of the damage to the structures and to the water supplies. So there is a kind of, obviously from this, an economic cost, but it's very hard to estimate. And there are a few that have had a go at trying to work this out, and all of these estimates are relating to England. There's some, but not many you can find overseas, but they're not particularly relevant here. The Committee for Climate Change came up with an amount of 156 million. That's per annum, a cost to the UK. ESI, which is a consultancy, came up with a value of 530 million, and I think the Environment Agency has sort of looked at those figures and reduced those to a degree, but I mean, still they're coming up with a value which is pretty high. And BGS, who I used to work for, came up with a value sort of up the upper end of about 300,000 per annum, and that was particularly high in chalk and limestone areas, and I'll be coming on to sort of explaining sort of why those are significant. And in comparison, that is, and these were figures from around 2015. The cost of the risk of flooding from rivers and seas was 2.4 million, and from surface water 3 million. So it's kind of small but significant amount of money. Okay, so we're getting on now to the causes of groundwater flooding, and there are many. I'm going to be focusing on the top two there, the two that are in blue. So clear water flooding, I'll explain what I mean by that, and river-driven groundwater flooding. But I wanted to touch on the other sort of causes and settings for groundwater flooding to occur first. So the first on the list there is urban groundwater rebound. So what do I mean by that? And this is a big issue across the world, actually, and in it has been in the UK. This is where in urban areas in the past there's been a lot of groundwater abstraction taking place, both for industry, but also for public water supply. But primarily due to issues with quality, that groundwater abstraction has reduced because the quality of the groundwater isn't good enough for the purposes it had in the past. And as a consequence, the groundwater levels that were sort of quite low have been able to recover and come back to their more natural levels. The problem is that in the meantime, there's been lots of development which has kind of assumed that the ground is not saturated. And we're thinking about, and specifically the example of London, a lot of the underground network was built and when the groundwater levels were relatively low, but also buildings with deep foundations, and that is resulting in flooding of the in some cases the underground and in buildings, and to the extent that the Environment Agency, Thames Water, and Transport for London came together and decided that they would come up with a strategy to increase abstraction of groundwater to try and maintain the groundwater levels at a low level. But this is a big issue that's been seen across the world, in Europe and Africa and many places. As has mine water rebound. So it's a kind of similar issue in case of mining. Abstraction was used to pumping was used to sort of lower groundwater levels to allow minerals to be extracted in an environment which wasn't sort of saturated. But as mining ceases, as it becomes less economic or environmentally not a good idea, then those groundwater levels can in places be allowed to sort of recover, and that water gets into the mines. It actually becomes polluted through the sort of the ore that's left, and in some places will come close to the ground surface or come out of the ground surface. So you both have issues of groundwater that is popping up in places that it hasn't been for decades or centuries, but also being of a poor quality as well. Subsurface construction, there's also issues, maybe not such a big problem, but where you have the constructions in very relatively kind of thin bits of aquifer that create barriers to groundwater flow. This is where you've got quite sort of shallow rocks. Has been a problem or thought that potentially could be a problem in parts of London, for example, in the posh bits where they're able to build their big basements and housing prices mean it's kind of it's an approach that people find sort of better than trying to sort of go and get bigger houses or build upwards. And that those barriers can kind of can cause water potentially to back up, and then groundwater levels to get closer to the surface and potentially cause groundwater flooding. Also, again, not such an issue in the UK is the change in land use and as a result, groundwater levels rising. So, and the photograph on the middle right is an example of a lake that's kind of expanded in extent in the Midwest in the US. And the reason here was that they got rid of the natural vegetation, which was very good at abstracting or taking the water that got into the soils and transpiring that. The agriculture that was brought in, the crops were kind of less able to do that, and so a lot of water was actually sort of able to get down into the saturated zone and causing the groundwater levels to rise. So that has been an issue in some places. I suppose a bigger one potentially is the impact of sea level rise. So as the sea levels rise and the groundwater tries to kind of discharge into the sea from the land at the coast, if the pressure of the sea is greater, it causes the groundwater levels inland to rise. And there are a lot of areas, not so much, but it's probably a problem in store in the UK, but certainly there's lots of interest in this in the US, a lot of low-lying areas, coastal areas that are suffering kind of regular nuisance flooding as a result of this new normal, which is causing groundwater levels to be close to the surface and coming up to the surface at times. So that's what that photograph in the bottom right is. And of course, sea level rise, it's part of climate change, and climate change is likely in the UK it'll cause more variability, certainly more rain in the winter, most likely rain in the winter, which will cause groundwater levels to rise. Certainly in some years, maybe not in every year, but we're certainly got a future of kind of more variability, and that will no doubt result in more groundwater flooding occurring. Okay, so moving on. So I said I would talk about these two primary mechanisms for groundwater flooding in the UK. The first we call groundwater flooding. It's pretty simple. It's where we get a lot of rain, over a long period of time. It causes the groundwater levels to rise, as shows in this little schematic on the left. And that can cause flooding of property, as in the photograph on the bottom right, low-lying areas. But it can also, as I was mentioning previously, can cause water to pop out on hill slopes and flow downhill, causing problems to properties it meets on its way and those in the low-lying areas. And the photograph top right is from the I think that's from the Marlborough Downs in the south of England, and issues with affecting transport routes. Now, in terms of, where do we see this happening? It's not all across the UK. And on the right, we have a map of the geology of the UK, but identifying the sort of the main aquifers, and these are the areas where potentially we could get groundwater flooding sort of from the rock, the sort of solid rock beneath our feet. So I'll pick out the chalk. So this is the chalk, which covers quite a lot of the east and the southeast of the country. The limestones, which are the areas in blue, and then the sandstones, which are the permotriassic sandstone. Apologies for the geological terminology, which are the sort of the light orange areas. And then there are other areas where we have other sandstones and limestones, which are the big sort of areas in orange. But these are all aquifers, but their kind of potential to cause to have groundwater flooding occurring are kind of, are not all the same. So if we look at, say, a borehole, which is in the chalk now, this graph on the right, it shows the groundwater level in black, varying across the years. This is from the sort of 60s up until to the 2000s. And you can see that kind of the groundwater levels vary, significantly over the years. We got some years like sort of the early 2000s where we had sort of the big groundwater floods. Other years where we have droughts because the rainfall has been particularly poor. But I think the point to make here is that we're seeing ranges of groundwater level over about 30 meters. So yeah, in chalk rock, groundwater levels can vary significantly. They can rise over quite relatively short periods, and they can, when they reach their heights, that groundwater will pop out and cause problems. Cause problems both to sort of near to the surface, but also with groundwater popping out at the surface. So chalk rock, and you can see the sort of extent of it here. This green is one where groundwater flooding is a particularly troublesome. If we look now at our limestone, and again we've got groundwater level shown in black. We've got this is the elevation again on the left, going from 0 up to 30. So with the limestones, not quite a sort of significant variation in levels as with the chalk, around about sort of 20 meters from sort of the minimum to the maximum. But it does, limestone, a bit like chalk, you get a huge big variation. The limestones tend to actually sort of see rises, quite fast rises in groundwater levels, but the groundwater level tends to sort of fall back down again relatively quickly. But still, again, these limestone areas are areas where you do see a kind of significant amount of groundwater flooding. We compare that to these areas where we've got sandstones, and now I think you'll see on the left the elevation of the groundwater level goes from about 60 up to 65. So this range is only about 4 meters. So there really isn't quite as much variation in groundwater levels in these sandstones as you see in other types of rock. So generally the issues with groundwater flooding are kind of less in these parts of the country. I mean, I should say there are always kind of local variations in this, and it's not to say that the chalk and the limestones are the only areas at all where you get groundwater flooding, but they are the ones where most of the interest has been in trying to address the risks of groundwater flooding. This is chalk. This is a kind of quarry face with some chalk, and we can see that we've got a very sort of small amount of soil, and then we get into this rock with lots of cracks and pores. And I suppose the point is this is kind of why you get rainfall able to kind of cause groundwater levels to rise so rapidly. The water that falls on the ground surface can very quickly get into the rock and cause the groundwater levels to rise. But on the other end, it does actually take a relatively long time for that water then to drain out of the rock. So it needs to go sideways to sort of to drain out to lower the groundwater levels. And if we look at this map on the right, and this is kind of covering mainly sort of Hampshire in the south of the country, you can see that there are relatively few rivers, certainly compared with other bits of the geology around. And this is the reason why, part of the reason why chalk, it just takes such a long time for the groundwater levels to go back again to sort of normal levels after you've had a sustained period of groundwater recharge. And this is a little sort of snippet of one of those plots that I showed you earlier. And this is for 2014, which was a sort of a period of really quite serious groundwater flooding. And this is just the top of that sort of the graph that I showed you. Here we're going over sort of only a sort of about 8 meters of rise. This is at the very sort of peak of groundwater. But you can see that, and then this is from a borehole where the Environment Agency have identified a level at which in the vicinity or in the area that's kind of representative of it, you will get flooding if groundwater levels go past this level. And what you can see is that it goes a bit beyond that level in February, and it doesn't come back. It doesn't go back down below that level until into June. So we're talking about 4 or 5 months where there is kind of the likelihood of flooding occurring in that area. And this is seen across kind of many parts of the sort of the chalk outcrop of the east and southeast of England. And this is one of the big issues where river flooding, which has its, serious impacts, may come and go in a kind of period of a week or so, and we can start the recovery process. It's a much longer, perhaps the impacts are less in terms of kind of the extent of the flooding, but it will certainly takes much longer to for those flood levels to recede, and this is part of the issue with this type of clear water flooding. Now, the other other setting that I mentioned right at the start was river-driven groundwater flooding. And this occurs where we have now permeable superficial deposits. I use that term because it is the term that's kind of used by the Environment Agency and others. But what are we talking about? We're talking about sort of sediments, very permeable sediments that sort of have been deposited over many years by rivers, and they occur in our kind of floodplains. And this river-driven groundwater flooding occurs because the river is in such good contact with these very permeable materials. And as the river levels rise due to rainfall that occurs in the sort of catchment upstream, that river water, even though it might be contained by flood defences, that river water will get into the ground and it will cause the groundwater levels in the areas beyond to rise, and that can cause groundwater in the basements or at the ground level to get into properties and cause the sort of impacts that we get by direct river river flooding. Now, just to give you kind of an idea of the extent of this type of flooding, this is a map that was produced through this Project Groundwater that I mentioned previously, and they have mapped in this green the sort of the areas where you've got these river floodplain sediments, these very permeable sediments, in contact with them with large rivers. So they're quite significant areas, and this is kind of, this area is covering West Berkshire, Oxfordshire, Buckinghamshire, Hertfordshire. So quite large areas where there's the potential for this flooding to occur. The area in pink, should say, is the chalk within this area. But we're looking at this green area in this case, and that can coincide with some big conurbations. So this area where I'm pointing to at the minute, that's the city of Oxford. There's Marlow, potentially we see this sort of effect in Watford and Hereford, Hertford, sorry. So it is, I suppose, relatively small in extent in the locality, but there are quite a large number of these areas dotted around the country. So I was just going to show you a little bit about Oxford, my home patch, just to sort of help illustrate what I was saying. And this is a figure which kind of shows the extent of these kind of floodplain river sediments. So there are sort of sands and gravels covered by, which are the sort of brown areas covered by alluvium, which is more sort of silty material that sits above it. But it occupies all the sort of low-lying areas in Oxford. And this is where the sort of city centre is located. But there are plenty of population of the population that are located on the floodplain, and the River Thames sort of comes through. So that's the kind of big river that's in connection with these permeable deposits. And this just tries to sort of illustrate that these are relatively thin sediments that sit on top of a kind of impermeable clay beneath. And we're looking at sort of only about 6 meters thickness. And what this map does is it shows you the depth to groundwater. So and this is the sort of just the extent of those floodplain sediments within the Oxford area. And we can see that the groundwater is, in most cases, kind of less than a meter below the ground surface, and where it's not, it's usually because the ground has been sort of built up, whether it's to do with this is a waste dump and these are some local roads, but mostly the groundwater level is very close to the ground surface, so it doesn't take much for those rivers, which are kind of contained to a certain extent, to cause groundwater flooding by sort of pressuring the water and causing it to pop up in areas which are actually protected from that river flooding. If we just look at South Oxford, which is the area that marked by this square, and here you can see lots of greenness, lots of fields, playing fields, parks, but in amongst that you have these properties, these houses, networks of roads, and what happens during a a flood is that we get lots of fluvial flooding, lots of river flooding, filling up the floodplain, lots of complex routes for that river water to get onto the floodplain. But in amongst it, areas which don't get flooded directly by the river. But what happens is in these areas, this river water makes its way through the sediments and pops up in the properties that sit within these areas. And what we can see is in a limited number of cases within these areas, you get flooding of the sort of beyond the ground floor by groundwater, but more of an issue is where people have basements and the groundwater levels have come up and the basements get inundated. It can affect gardens, and that was where the photograph was, sort of the initial photograph, but that's not such a big issue. I suppose kind of the main issue that affects most people is related to the sewers. This is actually a storm drain. I couldn't get a photograph of a sewer that was full of water, but it affects people's toilets. And in some cases, you get backflow of sewage coming back into people's houses. So that's the kind of the big issue. So that is a sort of an example of river-driven groundwater flooding. Okay, so something a bit about the kind of, the policy environment and kind of the authorities and who is responsible. As I sort of said at the beginning, not quite my area of speciality, but hopefully there's something here that's of interest. I'm sure some of you have, much more knowledge about this area than me, but with a focus on groundwater flooding. So who are the sort of, where are the responsibilities in terms of groundwater flood risk management? It's slightly different across the UK. I've got a bit more of a sort of England focus here, but hopefully you don't mind. But we'll cover on some of the other parts of the country. So in England, the Environment Agency is the lead authority for strategic assessment and mapping of groundwater flood risk. And it produces national flood risk assessments and strategic flood maps, and that includes groundwater flood components. And it provides data and guidance to the lead local flood authorities and other partners. Elsewhere in the UK, there are organisations which have a sort of similar role to the Environment Agency in England. So the Scottish Environment Protection Agency and National Resources Wales. Northern Ireland, the setup slightly different and it's more centralised. The Department for Infrastructure undertakes kind of all aspects. In the rest of the UK, lead local flood authorities and that's both in England and Wales, but local authorities and councils in Scotland have quite significant responsibilities in relation to groundwater flooding. So under the Flood and Water Management Act 2010, these LLFAs are the lead authorities responsible for local assessment and management of groundwater flood risk. They need to prepare local flood risk management strategies, and those, as I say, address groundwater flooding. They also address flooding from surface waters and from minor watercourses. And their job is to coordinate with other risk management authorities, such as the Environment Agency, water companies, internal drainage boards. But they are the LFAs have the primary responsibility. They're required to investigate significant flood incidents, including groundwater, and these are published as part of Section 19 reports, and maintain a register of structures or features at risk from flooding from all sorts in their patch. But they're not legally required to address the causes of the flooding. They may do, but they're not, as I understand it, legally required to do that. They often work with the highways authorities, the water companies, and the EA to manage surface water drainage. And they are statutory consultees on surface water drainage. And I mention that because it's kind of very relevant in the context of groundwater. They manage that for the major planning applications. Um, um, and I, in the context of sustainable drainage systems. As I say, I've talked a little bit already about the roles of elsewhere in the UK. Now there are other organisations, and just kind of quickly, the water and sewerage companies, they manage flooding from public sewers and surface water drainage systems, which kind of can relate to groundwater. They're responsible for maintaining critical drainage infrastructure and capacity planning. The highways authorities responsible for drainage and roads and highways, and hopefully you'll sort of see the link in here. If we think back to the kind of the impacts of groundwater flooding, these are all things that are where they have relevance to groundwater. Internal drainage boards, I suppose they're sort of don't cover all of the UK and really looking at low-lying and rural areas. But then there are the local resilience and forums, the resilience partnerships. These are the multi-agency partnerships coordinating emergency planning and response. And, so they will need to be aware of kind of the impacts of groundwater if that is an issue within their patch. And then in terms of, there are also landowners and riparian owners who need to maintain the flow and condition of watercourses, and there may be some relevance to groundwater flooding in that context. And then developers and planning authorities. So local planning authorities need to ensure new developments manage flood risks sustainably, and that may relate to groundwater. And also developers must incorporate sustainable urban drainage systems within their plans, and again that will relate to groundwater in some circumstances. And there's a question that was submitted before the talk, which I'll deal with sort of towards the end, which kind of illustrates the requirements in that context, actually relating to Wales, and there is a sort of difference between Wales and England in that context. So there are issues, of course there are issues, and I'll just sort of quickly go through some of these, and I've got some notes just to sort of to remind me. Ambiguity of responsibility and governance. So the Flood and Water Management Act, it assigns kind of responsibilities for lead local flood authorities for these local sources of flooding, which include groundwater. But some of those responsibilities are not really clearly defined, and the boundary between the Environment Agency, the LFAs, the water companies, it's can be a little confusing, and things will potentially not get covered as a consequence. In terms of data and mapping limitations, well, groundwater flooding it is complex. It varies spatially. Some of these available data sets that we have, these tools, are maybe too coarse to identify these local risks accurately. And they may not be sort of detailed enough for local planning or property level assessment. In terms of scientific and technical uncertainty, and this kind of links into the sort of the availability of tools and data sets. Groundwater processes are difficult to kind of understand. The amount of available data to be able to kind of fully understand those is limited, and in some places they're very slow to groundwater floods to start, and they're long duration, and it's quite hard kind of really kind of to understand the sort of and to predict the timing and the persistence of flooding. So it remains sort of scientifically sort of quite challenging. In terms of funding and resource constraints, I mean, LLFAs are kind of under-resourced, full stop. But particularly when it comes to sort of technically complex groundwater risk assessments, these there may not be the resources, there may not be the staff, they may not have the kind of the understanding necessary. And a lot of funding streams are geared towards fluvial and coastal flooding, not groundwater. And the monitoring that's required is kind of limited and expensive to maintain. So these are all issues sort of that that kind of constrain the management of groundwater flood risk. In terms of integration into planning and development control, I mean, national policy requires flood risk to be considered, but groundwater flooding is often overlooked. It's sort of poorly addressed, or just kind of really not understood, not dealt with because it's too complex. And that complexity is also kind of comes across in sort of communication, public awareness. Public don't really understand groundwater in the same way that they do, say, with kind of perhaps surface water flooding or river flooding. And they're also kind of limited sort of in terms of the warnings and the alerts that are available specifically to groundwater, which isn't sort of helping with the public perception of groundwater and the threat that it has. I mean, I've mentioned monitoring and a lot, but I mean, England does sort of lack a national groundwater flood forecast or comprehensive one. There are areas of the country that are covered, and part of that is to do with the available monitoring network, and a lot of boreholes were kind of installed for abstracting groundwater initially, so they're not in places that are necessarily the optimum ones for monitoring groundwater flooding, and yeah, climate change. I mean, it's kind of not fully understood what the impact will be on groundwater, and is that sort of future impact really being taken into account with the kind of current assessments of groundwater flood risk along with other types of flooding? I mentioned early warning systems, and they do exist, and the Environment Agency does have a groundwater level monitoring network, and that network where it exists is linked into flood alerts. Those are mainly sort of in the south of the country, in sort of areas where you have this chalk rock at outcrop, and there are other areas where they produce reports about the status of groundwater flooding. And then the flood forecasting service, which is also sort of partly operated by the Environment Agency, but also by the Met Office, it has a sort of larger number of monitoring boreholes that it uses to model the future groundwater flood risk. And this is an example of one of them to the right, but and where it uses kind of sort of different potential rainfall futures in the short term to sort of come up with groundwater flood potential and therefore leading into warnings. But it's still not, doesn't cover large areas. And Project Groundwater is as I mentioned previously, Project Groundwater is kind of looking at areas primarily of the chalk, and that's also developing a sort of similar system, which is helping to kind of expand the area that these groundwater flood alerts cover. So what can people do, and where to start? I mean, I suppose I would say initially, groundwater flooding is quite a hard form of flooding to do anything about. Not to say that there isn't anything, but it is where with water that's sort of coming over the ground towards you, you know, there are things you can do to potentially divert that water. When it's coming up from beneath, it's much more difficult. And I've divided this up into sort of household and local level measures, and those that are kind of more of at a larger level, I've called them municipal. And kind of in the spirit of it's difficult to know what to do, a lot of it is about sort of the type of measures to make your household more resilient that would be used in areas prone to other types of mechanisms for flooding, you know, river flooding and surface water flooding, which is about just making your house in a form that it can recover from the flooding, accepting that flooding is likely to occur. So, you know, as you're building back to have introduced flooring, electrics at a right height, the sort of measures that you would, as I say, you would sort of you would think of in relation to river flooding or rainfall source flooding. And again, flood barriers. So I talked about kind of the groundwater flooding can sometimes come at you down the slope from where the water is popped out on these kind of these temporary springs that occur. So it may be that flood barriers are appropriate in some circumstances. Not if the water's coming up from the ground, but if it's come up from the ground elsewhere and it's moving laterally towards you. Now, there are circumstances where pumping for households or small groups of buildings can work. And I know in Oxford, there are a significant number of properties where they have put in pumps within sumps that have trigger levels where the pumps are automatically start up, where that is significant enough to keep the groundwater levels below the level of their, well, it's the floor of their basements, you know, basements that they've converted into living areas. It may not always be quite sufficient, but it certainly, if it doesn't keep the water out, it keeps the water at a low enough level that you don't get as much impact on those habited areas. And I mean, the problem with these aquifers is they're very permeable, so it's quite hard to sort of pump and really reduce those groundwater levels significantly. But it's been shown that can work in some circumstances. And in some properties, they've kind of combined that the sump and pump with some tanking. Now, this is usually in circumstances where they've kind of built back from some quite significant impacts of groundwater flooding in the past, and stripped back the plaster and put in kind of serious sort of waterproof membranes, both on the sides of the walls but also on the floor. And you can see an example of this on the bottom right. This is a local property, and here they've got a combination of tanking, and they've got you can see that sort of, it's a sump bottom right with some pipe work which is connected up to the pump. So we're not talking about tanking in terms of kind of sort of painting on some sort of, you know, some cover over existing plaster. That doesn't tend to work so well at all. So it's you know, in this property they really sort of stripped things back and did the tanking properly. So that is an approach which has been shown to work. But I mentioned it earlier in terms of the valves to stop pipe, I should say wastewater backflow. one of the issues is as water gets into the sewage network, that water can then make its way back into the house, coming the other way from it's supposed to go. So having some sort of backflow valves can be helpful in some circumstances. And then there's been some talk about kind of local drainage systems. So, there's potential to maybe put in sort of drains or soakaways that can take groundwater away as groundwater levels rise. I mean, I think here you need to just need to have somewhere for the water to go for a start, and that will come up as one of the issues that you'll see in one of the questions that I've answered later. But you also need all the kind of the elevations to be right, that you've got a sufficient sort of gravity will be able to take that water off to discharge somewhere that's away from the house, and that's not always possible. So looking at a sort of municipal level, and I should say some of these are kind of theoretical. I think there are some examples in the sort of scientific literature that addresses these, but not always things that have been shown to work at scale. I mean, this figure on the right is an example that was discussed in a paper in 2021 from Australia, where they're proposing for a new development to build it up from the ground level and introduce a sort of network of drains that would kind of were new and would be part of the development. So there's potential to sort of I know for most people here, they're not involved with development, but that's that sort of issue. Of course, you'd ask the question whether this was sensible in an area that was prone to flooding to be developing anyway. I talked about the installation of backflow valves. There is a good example in Calgary in Canada where they've made it compulsory for any new developments, and they're also working on sort of existing developments that that people must have backflow valves and sumps and pumps installed, and that there's been some work to look at kind of the economic benefits of that, and it's really quite substantial. So that's a situation where that's worked really well, and that's a location that's very sort of similar in its physical nature to the Oxford example that I showed you earlier. And in that context, where I was talking about rivers being the kind of cause of the groundwater flooding, the rivers sort of forcing water into the permeable sediments associated with it. There may be occasions where you can manage those river levels. If you can keep them down, then you're reducing the kind of potential for groundwater flooding beyond the river. So there may be means to sort of increase the sort of flow of floodwaters down a river, as long as you're not impacting on those sort of downstream, that keep the river levels low and therefore reduce the groundwater flood risk associated. I mean, there are other things that are talked about in terms of putting barriers sort of in the subsurface next to rivers. But of course, that's going to have a potential environmental impact because the rivers are sustained by groundwater for large parts of the year. What impact would that have? But you might be thinking about sort of situations where you have got your flood defenses. That you're going to get groundwater flooding occurring beyond those defenses, but you combine that with some pumping. And in a sort of different kind of physical setting, there are locations where or a location, one that I know of where they're looking at sort of using pumps from serious big pumps from a group of boreholes to try and lower groundwater levels to reduce groundwater flooding. And those boreholes kind of exist because of a groundwater scheme that's used to augment stream flow during the summer when levels get too low. But looking at potential for reducing groundwater flooding at the other time of the year. Okay. And then finally, sort of on the municipal level, thinking about infiltration of water to sewers. I mean, one issue, one thing is to sort of to stop surface water, flood water getting into the sewers, because that can kind of, you know, will inundate the sewers and stop it doing the job it's meant to. I mean, one of the questions later on actually sort of addresses this issue, you know, looking to use sewers as a potential for getting rid of surface water floods. But that is as problematic, and it may, you know, maybe the efforts are more about protecting sewers by stopping surface water getting in there by measures that address the sort of the entrance at the surface. I'm trying to remember the word, but the manhole covers, so that, you know, that water can't get in during surface water floods. But also there's the potential to line sewers to stop groundwater getting in beneath surface. But this is a kind of very potentially costly thing to do. I mean, we all know about the issues of leakages from the main system. You know, also similarly, you know, leakages into the sewage system is a costly job. But there are examples of, in some areas, and I've included a map that was produced by Thames Water of I think it might be the Chesham area, where they're doing a sort of monitoring of groundwater levels and flows in sewers to try and identify where where most of that groundwater is getting in, so that they can sort of they can focus their efforts. I mean, one thing to focus their efforts to repair the sewers to stop water leaking in. One thing that was kind of, this came from some work that was done in the US, was that they'd noticed that by stopping water getting into sewers, it was actually causing the groundwater levels to rise, because those sewers were acting as a subsurface drain. So yeah, just something, you know, that needs to be taken into account. You know, as a sort of you know, unintentional consequence of trying to fix a problem. I mean, in terms of what you can do, well, what we're looking at in South Oxford is not really sort of a measure to stop flooding, but at least a measure to help people prepare for flooding. And the question is, given that this groundwater flooding is caused by increased river levels, can we look upstream in the Thames at river levels, which we can get easy access to through the sort of the live Environment Agency monitoring network that's available via the webs. You know, can we look at that? Can that give us some indication of when the groundwater flooding might occur? And this red line is the river level up at this point, sort of in Incham upstream of Oxford. The green is kind of the river level sort of next to our properties in South Oxford. The black is the level in the borehole, and once it gets past this sort of dashed level of this dashed line, that's when we get groundwater flooding in our properties that are sort of protected from the river flooding. Can we use this information to sort of help us to warn us of when there is the potential of groundwater flooding? So that's something kind of we're looking at the minute. Of course, there's the question of flood insurance in relation to groundwater flood risk. From what I can see, standard home insurance, and this is kind of quoting an article that was in Which earlier this year, groundwater flooding may be covered and the term they use is if it's built up rapidly, but not where it's risen gradually. So I mean, I think what they're trying to avoid is rising damp or persistent waterlogging being considered as groundwater flooding, but it's not completely clear what's meant by built up rapidly. But in terms of flood re, this does say there will be payout when damage to your home is caused by groundwater flooding, so it is covered. But it says, however, the groundwater has to enter your home from outside and has to do so with substantial and abnormal volume, weight, or force. So does that, does that mean groundwater levels coming up through your floor? It should do, but it's not clear. So I think, the message is you need to check with your insurers. The kind of question mark I have is, do your insurers really kind of fully understand groundwater flooding and the sort of mechanism for flooding? But that is the kind of safest thing that you can do. Okay, so that sort of takes me to the questions. Hopefully you found that of interest and of some value. The questions, there were 3 questions that were asked of me before the meeting that I was able to do a little bit of preparation on. I can see Jean has reappeared, so I don't know if you want to sort of, whether I should just carry on, Jean.
Yeah, carry on, David, with the ones that you've had already, and then there's just one in the chat from Kath. So it doesn't matter which order you want to do this. If you want to carry on.
Yeah, I'll try to be sort of relatively brief with this, but I think we'll probably use up our full hour and a half. So the first question we got was, well, just to provide a little bit of context, it came from Wales. It was in relation to recurrent flooding along the Manthrig, excuse my pronunciation, watercourse, which was potentially, these are the words of the person that sent the query in, potentially worsened by a proposed housing development at Pentyborfa with questionable attenuation design. But the questions were, and these are sort of generic questions, what technical and regulatory mechanisms exist to require the developer to undertake a comprehensive site investigation to establish true seasonal groundwater levels? And can the lead local flood authority, local landowners, or even the insurers be obliged to contribute to an integrated groundwater and surface water management solution? So I think we're talking about a potential development in this case. So under the Flood and Water Management Act 2010, which was implemented in Wales in 2019, all new developments of one or more dwellings or of an area of 100 square meters plus of impermeable area require approval of the Sustainable Drainage Approval Body before construction begins. Now, this is in relation to Wales. So these, as I understand it, these sustainable drainage approval bodies don't exist yet in the UK, although I think, sorry, in England, although I think they're due to be brought in soon. And this, so they will require SUDS designs that go with a new development, that they require them to comply with the statutory SUDS standards for Wales. So this is something, as I understand, as I say, doesn't apply in England, that that there's not a statutory requirement in England. It's more advisory in relation to these SUDS. But in Wales explicitly require a comprehensive understanding of local ground and groundwater conditions to ensure SUDS are suitably designed, constructed and maintained. And the developer must undertake site investigations, including seasonal groundwater monitoring in October to March at a minimum, or where there may be issues with during summer periods, or 12-month 12 months in groundwater sensitive areas, and undertake infiltration testing in accordance with the BRE and Syria guidelines. So there is a requirement to do that, and if the developer cannot demonstrate adequate site data, including this groundwater behaviour, this SAB can refuse approval and construction cannot legally commence. So it's not guidance, which, as I understand it, it may be in England. It is a statutory requirement. So hopefully that partly answers the question. In terms of planning, the planning policy in Wales requires that all development proposals consider all sources of flood risk, and that includes groundwater. And the developments must be accompanied by flood consequences assessment where it's relevant. And that is set out in the technical advisory note 15, and that requires comprehensive assessment of flood risk from all sources, including groundwater and surface water interaction, and it must be informed by site investigation and hydrological understanding. So this is, I think there may be some sort of flexibility there, or it's more guidance, but you can kind of still relate back to that requirement that SUDS, that there must be the data that shows that SUDS will not exacerbate flood risk, and there is a sort of statutory requirement. So that is quite a sort of significant curtailment of activities should there be perceived to be a significant risk from what the housing developers are planning. In terms of that question of is the LLFA or the local landowners or insurers obliged to contribute to integrated groundwater and surface water management solution? As far as I can see, they're not obliged to fund solutions. Although they may sort of voluntarily participate in partnerships. So there's, but I'm not quite sure how that sort of fits with, presumably if it's a new development, you would hope that the assessment meant that there wasn't there wasn't going to be a risk. So there would be no need to contribute to a solution, but as we know, it's not always the case that all risks are addressed in advance. So, but the legislation says that they're not obliged to fund solutions. Then we've got two other questions, and they both sort of cover the same sort of issue, although coming at it from sort of quite different perspectives. So the context here was the impact of damp. There's impact of damp on a structure which somebody has recently bought, a house from about 1910, which it's thought is possibly due to public road and path construction, providing a barrier to natural groundwater flow. So you can see a photograph of the house here. So presumably some of this these pathways and roads were sort of built since the house itself was built. And the question is, who's responsible for the management of groundwater flooding between the boundary of a private domestic residence and the area authority drainage system? And is the local authority obliged to provide access to their network to discharge groundwater? So the owner is thinking about putting in some sort of drainage system to lower the groundwater levels beneath their house. But as you can see in this area, it's they're limited in where they can discharge that groundwater. They're wanting to know, can they put it into the authority's drainage system? Now, there's a separate question from a flood warden in a village affected by chalk groundwater flooding. And the question there was, is there any specific law or building regulation that states categorically that one cannot pipe a groundwater spring into a foul water sewer? What I've found is sort of in terms of, well, I suppose top line is there's no automatic right to discharge groundwater into the public drainage network. The Water Industry Act 1991, property owners have a right to connect surface water drains to the public surface water sewer, and that might be a combined sewer, so it's both surface water and foul water in older urban areas, but they can't discharge groundwater. Surface water in this context means runoff from roofs or paved areas caused by rainfall, but groundwater, and that includes springs, so it relates to the third question, are classified as clean or non-foul water. So they can't be kind of connected into the drainage network. From what I could see, there are exceptional circumstances where if no viable drainage option exists and flooding poses a serious risk to life or property, the water company may agree to a temporary or controlled discharge, but that is discretionary. And the question was about other legislation that sort of addresses this, and the Building Regulations 2010. They talk about the foul water drainage system that should carry foul water only, and surface water drainage systems should only carry surface water. So that kind of, again, says that groundwater, which isn't classed as either of those, can't be legally discharged into them. Now, this gentleman, the property owner who posed the second question, I suppose from additional information he provided, there may be a case for saying that water is in fact not groundwater, but it's runoff from roofs or paved areas. So that may be the kind of route that you need to go down. But otherwise, it's a conversation with the water company and the local authority, and which I believe so far he's had little success with. I mean, there's no operational duty. The local authorities have no operational duty to take groundwater away from private land, as I understand it. There can be circumstances where permission is granted to connect the highway drain, but only where the drain has capacity and won't cause a nuisance. That's the Highways Act. And the land drainage or ordinary water courses could potentially, water could be linked up to those. And that would be via an ordinary watercourse consent, and that's referred to in the Land Drainage Act. But again, something you'd really need to follow up on. So that's all the questions I had in advance.
There was one, David, and it was from Kath in the chat. Are you aware that officially there is no statutory consultancy for groundwater flood risk in the planning system? Is that right?
I will take Kath's word on that. I think it
was.
I think
she said that yeah, she said it came up in an issue in the examination of a local plan in Spelthorne, Surrey. Both the EA and the Surrey LLFA claimed they weren't the statutory consultee for groundwater.
Right.
So it's probably something people come up against a lot.
Yep. Yes, I would need to have a think about that.
Can we take that one away? Should we take that?
Yeah. I mean, I would have thought if the LLFA is a statutory consultee, and if they're responsible for groundwater flood risk, then I would have thought that. But yeah, as I say, it's not my area of expertise, so I'm sure there are lots of sort of subtleties in all of this that that people in the know will be far better able to answer.
Well, if we can find anything on that one, Kath, we'll come back to you on that. But failing that, just coming up to 6:30, so I'd say thank you so much, David. That was really interesting and fascinating. I certainly learnt loads on that. The recording will be available and we will put it on our website as soon as we've got it detailed. And I think, David, you said that a set of slides will be available. Is that
Yep.
right?
Yep. There
So,
might be one or two little bits that I have to take out, but yeah.
yeah, that's fine. So we'll make those available as well. Anybody who wants to see those, if they just email me, that would be fantastic. So yeah, I'll end this now. And thank you everybody for attending. Thank you very much, David. We really appreciate it.
Okay, good. Thank you. Thank you for your attention.
Thank you.